we spent a whole lot of time talking about inverse trig. And when I was glancing over IXL, I realized that IXL has some things I didn't talk about, so that's why I didn't assign it. IXL is going to ask this very similar questions, but in a slightly different manner. Uh, and it's still inverse trig. And usually what they will do is they'll give you a restriction along the top. I've only had a couple hours of sleep, so my spelling and ability to put things in a, I'm going to sound like a combination of Joe Biden and Donald Trump right now. I'll put it that way. Pretty bad. Usually it's going to list some kind of restriction, okay? Like theta is stuck between, and it might have an equal symbol, but negative pi over 2 and positive pi over 2. The angle is located somewhere in there, all right? And they will tell you that the sine of theta is negative root of 2 over 2. So what you will do is you will think about your unit circle. I'm not going to pull the unit circle out here. But to be trapped between negative pi over 2, positive pi over 2, you're talking about an angle somewhere in here. Do you understand that? So theta lies here. Now, just a kicker, because this one's on the unit circle. Somewhere on the unit circle, there is a y value, right? Because it's sine, a y value of negative root of 2 over 2. It's got to be down here somewhere, doesn't it? Somewhere right here, there's a point that says negative root of 2 over 2 and negative root of 2 over 2. Now, Trevor, I'm assuming you've memorized the unit circle. Sine is y, cosine is x, tangent is y over x, okay? So you guys all did with the exception of Trevor, who's going to do it next day or two, you all did the unit circle quiz. What's the angle right here? What the angle? Angle. Y'all crammed it and forgot it, didn't you? You don't have a 2. 225 is the angle, degrees. IXL would reject that. 5 pi over 4. Why would IXL reject that? Look at the restriction. The question is talking radians. Okay? The answer is going to be talking radians. If you're in Spanish class, you answer in Spanish. Maybe not. I don't know. It's been a while since I've been in Spanish class. Let's do another one of these. And some of the IXL questions I glanced at, they do have degrees. So theta is between 0 and 180 degrees. So talk about 0 to 180, you're talking about this thing right here. What function y'all want to use? Give me a trig function. Okay, cosine. Cosine of theta is given as negative 1/2. And, you know, to go negative half, that puts you, go back a half unit, puts you up there on your unit circle. So, think about the actual angle. It's this. This is the actual angle. Let's measure that angle. That's 2 pi over 3. That's 120 degrees, which is why I kind of use the visual aspect. It looks like about 120 degree angle. That's 2 pi over 3. So that'll handle that part. That should kind of more or less be able to get you through the section that talks about inverse trig. It's not hard. They just kind of give you an idea of what they want to be. And there are some questions. We should do at least one of those. Tangent of theta equals 1, and theta is trapped between 0 and 360 degrees. There's two answers to that. Tangent is y over x. Okay? So what we're doing is we're thinking about the spots on the unit circle where y and x are the same, because if tangent's y over x, we need to divide them out. Now there's a root of 2 over 2 here. Back here, don't be tempted by these, because those won't generate ones, will they? And there's this guy right here. This one ought to be tempted. Do you understand that those are the two places where the tangent ratio is 1? Now, because I'm talking about full circle, I give both answers. And this one is talking degrees. What's the angle right here? 45. And this one right here we did earlier. That's 225. That'll get you through M9 on IXL. So now let's try and get you through M10. I'm too tired to make these particular questions up. Anybody got any questions before I move on?
What did you say there at the end? Which one did you say was the easiest? Why not the one in the second question?
If you do this one, if you do your y over x here, you've got a positive root of 2 over 2 divided by a negative root of 2 over 2. What kind of one does that create? And you're interested in the positive. And this one down here would do the same thing. The y value would be negative, and you would generate the negative 1. That's why you can't use it. Everything's got to be right, sign included. Good question. Anybody else got any questions? All right, so that should cover everything you need for M9. The next thing I excel is M10, and these are really baby level questions. They're not, but anyways, I'm embracing this no homework thing because it's really easy on me. So baby questions is what we're doing. That's what we're doing. Okay. Can't complain. Once this first 6 weeks is over and they tell me I can give homework again, we'll up it. So if you're looking at IXL M10, M10 is solving trig equations. Now, I think your group got a taste of this in Algebra 2. It's not tested, so it's not something that I really push too hard. They're actually pretty simple. Here's an example. 2 sines of x. If you don't like x, put a theta. Minus root of 3 is 0. Now, in the previous section that we did, we just had sine of theta equals something, right? That's the goal. The goal of this question, the goal is to say sine of theta equals. Get it to that point. How do we get that problem to that point? Add a root of 3. And I'll change that x to a theta because IXL uses theta. What else you do? Divide by 2. So you know that the sine of theta is a root of 3 over 2. Now, this question had no restrictions. It didn't talk about anything. So you give all the answers. Not just one, you give all the answers. Because there is more than one answer on this problem. When you're doing a question like this, since there were no restrictions given, and there weren't, you got to think full circle. If there was a restriction, it might have said between 0 and 180 degrees or something like that. This one gave no restriction, so it's all about the whole circle. So you think about your unit circle. You think about where the y value is root of 3 over 2. There's two places where the y value is the root of 3 over 2 on the unit circle. What's one of them? Pi over 3 is one of them. Two pi over 3 is the other one. 16/120. Right? Yeah. And that's solving a trig equation. Really not too hard. I'm going to do one that requires the assistance of a calculator. I can't just go through and see all the types of questions that IXL assigns. All I see is like a preview of the first couple. I don't get to see everything. But here's one that requires a calculator. And this problem is given with a restriction, although it's not a very good restriction. That theta lies between 0 and 2 pi, so it's a full circle deal, which means it has probably two answers. All right. So 9 tangent squares of x plus 2 equals 3. I know you had pre-count, did you? I don't know if I talked about in Algebra 1. Tangent squared of x is tangent of x times tangent of x. That's what it is. The reason we don't put the exponent here is because people want to square that argument. That's why we don't put it there. But anyway, it's just saying multiply tangent by tangent. So let's kind of go through the same procedure we went through last time. What are you going to do? You'll subtract 2. 9 tangent squares of x is 1. Divide by 9. Square root it. The opposite of squaring is square rooting. So the square root of tangent squared of x is the square root of 1 over the square root of 9. I'm just assuming you're doing things without technology. What's the square root of 1 over 9? Plus or minus? It's plus or minus. Now, did we actually figure out what x was, what the angle was? No. You're going to have to use a calculator for that. This particular question was about radians, so I'm going to put it in radian mode. I don't know that IXL goes into these too big. They really don't have a place in a calculus class. You can't do it by hand. You shouldn't probably be doing it. What's the opposite of tangenting? Arctangenting, okay? So arctangent of a third, which, wrong number there. Tells me that theta is about 0.322, round however IXL talks about it. And you've also got to take the arctangent of the negative 1/3. Now, that's only half the answers. That is only half the answers. Think about what you know about the unit circle and the fact that tangent is y over x. Wouldn't there be two spots where you maybe could generate the 1/3 like we've been doing in the past? Maybe two spots where you could generate the negative 1/3? There are. There are. In degrees, because this was a tangent problem over here. This was a tangent problem. In degrees, how many degrees were covered as you went from those 2 points that had the same value? 180 degrees. Which is equal to how many pi radians? 1. Okay. All we have to do is add pi. That's all we have to do is add pi. That's the other one. Now, IXL would probably want a decimal. So, you have access to a calculator. Add pi, round the third position or whatever it asks you to do. You'll have it. Let me glance at IXL real quick. Make sure I've talked about enough stuff. Because I actually do want you to spend some class time on that today. But the solving equations, oh, I do got to go over some dumb ones. I call them dumb equations. The first couple of questions you do on IXL are going to be the really easy ones before it actually asks you for some answers. So let's talk about some what I call dumb questions. And your typical dumb question will involve either sine or cosine. See, like, did you see that question? How many answers are there? How many solutions? Like the first couple questions you do are going to be really easy on that section. Before they ever start asking about what theta is. So here's a dumb question. It is a dumb question. Cosine of theta equals -2. What is theta? Why is that a dumb question? It's not there. It's not. There's not there. Yes and no. There is always a number that you don't have memorized on the unit circle, son. You just didn't memorize it. Somewhere on that unit circle is a decimal like negative 0.584 for cosine. It's there somewhere. You just didn't memorize where, right? It is there. Why is this a dumb question? What's the cosine ratio? According to the ratio that was given, the adjacent side is -2, and the hypotenuse is 1. It has nothing to do with negativity here. We just care about absolute values, their lengths, okay? It has nothing to do with negativity. According to the ratio that was given, the adjacent length is 2 and the hypotenuse is 1. Is that possible? No, it's an impossible thing. So there are some little things students are supposed to remember. Let me see how to, what's the best way to write this is probably in words. The absolute value of a sine, the reciprocal of sine being cosecant, cosine, or secant ratio cannot exceed 1. It cannot exceed it. In fact, on the unit circle, the largest value of either y or x is what? 1. There is no value of y or x greater than 1. Now, tangent and cotangent don't have those limitations. They do not have those limitations because they're about opposite and adjacent. They don't talk about the hypotenuse. Sine and cosine do. That's why they cannot exceed 1. Do you know where the sine and cosine ratios on a triangle are actually 1? At what angle? At what angle on a triangle are the cosine and sine ratios 1? Hmm? Well, I guess you should talk about the ratios independently. Sine is opposite over hypotenuse, right? What angle would have a sine ratio of 1? 90. Because the opposite side is hypotenuse, isn't it? When you talk about sine of 90, you're talking about a hypotenuse over hypotenuse. There's a 1. Zach mentioned 0 degrees. He's probably thinking about the unit circle. Well, there is no triangle to draw there, so I can't actually draw a triangle. But it happens at 0 degrees on cosine. So that's a typical dumb question. Be on the lookout for that. It has no answers. It's impossible to answer because it shouldn't have been asked of you. It's just seeing if you understand sine and cosine. What other dumb questions are there? Most of the questions are like, how many answers are there? Which shouldn't be too hard. There's always 2 if you talk about a full circle. Unless the question just didn't make sense. And we did a calculator problem. We did something with an exact number. You should be good to go on M9 and M10. So let's see how all you do. I am going to teach something tomorrow. It won't be long. So you're going to have some classwork time tomorrow too. But you should be good to go. You should be good to go on M9 and M10. If you're watching this at home, I'm sorry. I'm just really stupid today. At least you didn't have to be here in person.